first part of the accelerated motion lab. Today we're just going to, or this week, we're just going to try to get our apparatus put together and working and take some data. And then next week we'll analyze the data. All right, a little bit of discussion first. We probably are just barely getting to motion this week. But analyzing motion is the one of the first things we have to do in this class. We have to analyze it a lot in more detail than our average man on the street thinks about it. We have to think about it a lot harder. Most people can figure, well, if I go here to Chicago, it's 300 miles. It takes me 6 hours. My speed was 300 over 60. No, 300 over 6 is 50 miles an hour. But that's for a constant speed. So most people think about motion in terms of motion at a constant speed. If you travel 60 miles an hour for 1 hour, you'll go 60 miles. For 2 hours, you'll go 120 miles. But we have to talk about accelerated motion. Accelerated motion occurs when the speed of an object is changing. And the first person to think hard about this was Galileo. And he thought that the most common example, especially back then, of accelerated motion was an object. If I have this object here and it's not moving at all, its speed is 0, and if I drop it, it speeds up. Every instant it's going faster and faster and faster. So Galileo gave us the definition of acceleration, the rate at which the speed is changing. Then it turns out that if you start with 0 velocity, the distance you go in a certain amount of time is not proportional to the time, it's proportional to the time squared. And that's what we're going to observe in this lab. So Galileo wanted to study gravity, and he did, but it only takes a very small fraction of a second for that object to drop. And that was beyond Galileo's capabilities, measuring those small times. And indeed, here at home, it's beyond our capabilities as well. So Galileo had this idea. If I take a ramp like this, and the object slides down the ramp, it's gravity that's causing that acceleration also. The object started out at 0 speed and sped up as it went down the ramp. So he thought of the ramp tilted at an angle as sort of diluting gravity a little bit, so that it brought the times down to ranges that he could measure, and likewise we can measure here at home. So what do we need for this lab? Let me get my camera going here. I hope. Now we need some safety glasses. Need some safety glasses. 2x4 board. You don't need the hook. I have a stopwatch. You can use your phone if you don't have a stopwatch. Some masking tape, a marble. And we don't need the protractor. And a ruler. That's it. Not too much to get together. And our ramp here, our big board. All right, so let's get started. I'm going to take my safety glasses and put them on. I now have some flip down readers on my safety glasses. They're not real good. And move this stuff off the ramp. We need to mark the ramp. I put tape across here marking the marking every 10 centimeters along the ramp, up to 80 centimeters. You don't have to use tape for it. You can, if you can draw on your board, you can just make pencil marks every 10 centimeters, starting at this end down here. So this is 10 centimeters, 20. I got little arrows to tell me which side of the tape is the measurement. So you need your ruler to lay out the board like this. And then we're going to use an app. It's in the whatever they call that, the Play Store. Or I've got a description of it in the lab procedures. It's called an inclinometer. So tells when what the slope of something is. So the first thing I want to do is level my table. I'm in, this is a very old table, and I'm in a very basement of a very old house, and nothing's level around here. So if I lay the side of the phone down on this 2x4 here, notice that I do not want to, I do not want to let these phone buttons, I do not want the phone to be resting on its little side buttons. So I'm using this, I see I got a slope of 3 degrees. That's pretty bad. This side here is much lower than that side over there. So I want to jack up this table a little bit and try to get it kind of level. I've raised it almost 3/4 of an inch over on that end. Try again here. Didn't really help it much. Looks like I got to raise it quite a bit more. Okay, you can see that this this table surface is not very level. I also want to level it this way too. This inclinometer is only reading to 1 degree, and that's probably appropriate because I can see that a big range of uncertainty for me here is going to be the slope is not very uniform. See, there's a big bump, there's a big hump in this table. Oh yeah. Boy, this is really a cruddy table. There's not much, I got it 0 at the ends, roughly. I've raised, my camera's a little crooked, so you're, I've raised it more than an inch on one side. Table's got a hump in it, I can feel it. It's just level down at that end. Now it seems like the flattest part of this table is up here. So I'm going to put my board there. I'm going to slide this into about the, slide that 2x4 into about the 60 centimeter mark or so. And see what kind of slope my board's at here. I need to go in a little further. About 5 degrees up there. Look at this end. Boy, board's bad. It's only 3 degrees down here. That's pretty, I'll go in a little higher here. Ooh. About 5 degrees down there. About 4 degrees. About 4 degrees here. I think I want to prop this up a little better. I'm going to slide a box underneath there. Make it a little more solid. About 5 degrees here. About 4 degrees down here. That's pretty, I'm not going to do much better than that, I don't think. If you take a little more time, and you've got a flatter board and a leveler house, you might be able to get yours a little better. Now, what I'm going to do is obviously I'm going to roll the marble down the ramp. I think most of you have jumped ahead to that. And I'm going to put a box down here at this end so that when the marble gets down to the end, it will hit it and give me a sound to tell me to stop the stopwatch. So I'm going to start out here at 80 centimeters. Let the marble roll down, and I want the marble to go straight. It's not going very straight. You know, it's kind of sticking to my fingers when I let it go. So here's what I'm going to do. I'm going to take my ruler, and I'm going to hold it up with the ruler, and then pull the ruler out. It's kind of veering off to its left, so I want to maybe raise this side just a little bit. Need a piece of paper. Fold up a piece of paper. Slide it under here maybe a little. And let's see if it goes straight. Good. So I've got my ramp at about 5 degrees, and the marble's rolling fairly straight down it. So now I'm going to start out here at 80 centimeters. The times are obviously going to get shorter as we move to smaller distances. So I want to start out here because the more I use the stopwatch, the better I get. It's really nice to have an assistant for this. So let me get my clock. Stopwatch, start, stop, 0.4, start, stop, 0.33, start, stop, 0.26. See, I'm getting a little bit better. So now I'm going to try to release this, start the stopwatch, and stop the stopwatch when it gets to the bottom. I missed it. .63. Try it again. 1.76. Try it again. 1.7. 1.82. 1.7. You want to get, for each distance, you're going to have 5 time measurements. And you want them to be fairly close. .83. I'm going to try this with the stopwatch. Um, .78. .84. .81. You know, I'm going to double check my angles here. If you get the angle set right and get good at the stopwatch, you should be getting about 1.6, 1.7 seconds for this distance. So let me go back to my. Let me check my angle here. I think when I put that paper in there, Boy, this board is really warped. I think since I get such a low angle down there, I think I want to get 6 degrees up here or so. So I can get a little bit higher down here. It's getting worse. At least I got about 4 degrees here. I can see one big source of error here is going to be the angle. Now let me see if it's rolling straight. Pretty straight. Let's give it a try. Missed it. .7. That's good. As I said, should be around 1.6 seconds. 1.7 is around 1.6, good enough. 1.63. 1.83. 1.7. 1.7. 1.7. Pretty good. So I want to get about 5 times that are close together. Let's try 50 centimeters. It should be about 1.4 here, I think. 1.37. Good. 1.37. Good. 1.43. All right, so your job this week to get your system set up. Make sure you're getting about 1.6, 1.7 seconds or so from the 80 centimeter mark. And then try to get somebody to help you and somebody to write down the numbers for you. And if one person runs a stopwatch and the other person releases the marble, things go a lot easier. All I've got is my cat here, and he doesn't have opposable thumbs, so he can't do either of those things. Anyway, after you collect your data, you want to snap a picture of your apparatus. Try to get a handsome picture. Put my marble here. Okay, so that picture is going to go into your lab write-up, and then you're going to have a data table with that you'll make with 5 times measured from each distance. And next week we'll analyze that data. So we won't have anything to build next week. We'll just be making a graph and analyzing the graph. Let's see. I think it's probably a good idea to try to leave your apparatus set up if you can, unless you're doing this on the dinner table and you're going to have to take it down. Try to leave it set up because you might have a data point or something that looks a little wacko, and you might want to go back and redo that one particular measurement again. And see you next week.